I'd like to take a moment to welcome and introduce our panelists joining us today. First, we have Dr. John Morris, NASA's Astrophysics Division Director at NASA headquarters in Washington, D.C. We have Ned Wright, the WISE Principal Investigator from UCLA. Bill Iris, the WISE Project Manager from the Jet Propulsion Laboratory in California. Amy Meinzer, the WISE Deputy Project Scientist, also from JPL. And Peter Eisenhart, the WISE Project Scientist, also from JPL. And with that, I'd like to hand the discussion off to John Morris. John?
Hey, thanks, JD, and welcome to everybody. We're very excited here to be launching WISE, which is NASA's latest mission in the Explorer program. It will map the entire infrared sky to exquisite sensitivity and will enable breakthrough science. The launch of WISE caps a series of missions that have launched for the NASA's Astrophysics Division over the past 2 years. We had GLAST Fermi in June of 2008. The Kepler mission launched last March 2009. Hubble Space Telescope Servicing Mission 4 in May of 2009, and then also the European Space Agency's Herschel and Planck missions, on which NASA is a partner, launched also in May of 2009. All those satellites are up, doing great science now, and we're about to launch WISE. So let me go to the first graphic, which shows our current portfolio of missions. We see along the bottom there, you see Hubble on the right side, Chandra and Spitzer. Those are great observatories. We've added, as I mentioned, Kepler on the lower left and Fermi on the upper right. We also have the international missions that are labeled there, either the European Space Agency or the Japanese Space Agency on XMM, Integral, Suzaku, and then Herschel and Planck, as I mentioned. We also have a very important component of our program, which is the Explorer program, represented by SWIFT, RxTE, GALEX, and WMAP. And now on the next graph, we're about to add WISE. Not shown to scale, although I'm sure Ned would like the 40-meter version of WISE. The 40-centimeter version is what this is, and it's large to represent its newness. Now, WISE is going to do an infrared sky survey, and it's going to add to the scientific capabilities of Spitzer and Herschel in particular, which will be able to do follow-up observations based on new targets discovered in the WISE survey. Hubble will also be used to follow it up, and this sky survey will leave a legacy for scientists to mine in order to support future missions such as SOFIA and the James Webb Space Telescope. Finally, I wanted to mention that WISE is launching here at the end of the International Year of Astronomy. And we've spent the last year, along with many organizations around the world, talking about the excitement of astronomy and astrophysics, its accessibility to the public, and how it generates inspiration for students to go into STEM careers, for example. And WISE has a vigorous education and public outreach program, and many teachers and students will be participating in that. So now let me hand it over to the principal investigator, Dr. Ned Wright.
Thank you, John. So WISE will survey the sky with much improved resolution and sensitivity than previous surveys. This means that WISE will get much sharper pictures and be able to see much fainter objects. And as a result, it will see about a few hundreds of millions of objects. Now, many of these are stars and galaxies, so we can see at other wavelengths, but for millions of them, WISE will be the first time that we've ever seen these objects. So let me just say a little bit about how WISE is going to do its sky survey. So if we have the first animation going, we can see that WISE is orbiting around the Earth, following a path across the line between day and night on the Earth. And as it orbits, it surveys a strip of sky. And as the Earth orbits around the Sun, that strip of sky moves over. And after 6 months, we've completed a survey of the entire sky, giving us a new view of the universe. Now, infrared waves are longer than the waves of optical light. And so WISE is looking at light waves that are 5 to 33 times longer than the waves of red light that your eyes can see. As a result, infrared bands are good for studying cooler objects that are cooler than the sun or light bulb filaments that produce the light we see. Now, all objects that are warmer than absolute zero produce infrared light. And so if we look at the next graphic, you have an infrared picture of me. And the warmer parts of me, that's the skin around my eyes, actually produce the brightest infrared radiation. And the dimmest parts of the picture are where my clothes are blocking the heat from my body. So previous surveys, going back 26 years, have produced a survey of the sky shown in the next graphic. So this is an image of the whole sky, and of course it's dominated by the closest galaxy, which is our own. And because infrared radiation can penetrate through the dust that blocks our optical view of the center of the galaxy, the center is quite bright, as is the plane of the Milky Way. And you can see the Milky Way is very, very flat. So it's a very thin disk that we're looking at. Now you can also see that the dust that infrared can penetrate through is actually radiating infrared light. So you see the diffuse red emission in this false color image. That's actually infrared radiation from dust. And this comes primarily from regions where new stars are forming. So this is an exciting aspect of WISE science. So if we zoom into the galactic center in the next graphic, then we can see that previous surveys have given us a fairly blurry image when you actually look at this all-sky survey carefully. And that's because the camera that took this picture in particular only had 62 pixels total. So obviously nowadays we can do much better. And so with WISE, if we go to the next graphic, you can see the kind of resolution we hope to achieve. WISE actually is carrying 4 million pixels. So that's quite an improvement over 62 pixels. So with this WISE improved resolution, by the way, I should point out this is real data here, but we've actually only observed a very small slice of the sky to date with this improved resolution, and WISE will do it over the whole sky. So WISE will give us a roadmap that will be used by big telescopes. As John mentioned, we have the Hubble, we have Spitzer, we have Herschel, and we will have the James Webb Space Telescope. But WISE will provide the roadmap so that they can visit or point at the most interesting objects in the sky. So WISE is very much like a wide-angle lens, taking an all-sky picture. And the big telescopes are like telephoto lenses. And both are necessary for a skillful photographer. So WISE is going to be taking a lot of data. So we're going to be taking a 4-color image. We have 4 different bands every 11 seconds. And we'll be doing that essentially continuously throughout the duration of the mission. And that works out to millions of images. We will stitch these together to make a panoramic view of the whole sky. And this will then reveal to us many interesting objects. We expect certainly to see many asteroids, stars, and galaxies. But really, I'll be surprised if I'm not surprised by finding the unexpected, because we're going to find things that nobody has imagined yet. And with that, I'll pass it on to Bill Ayres.